So a couple people asked about different shapes of distributions. So I just Googled shapes of distributions and statistics, and I found this Khan Academy resource. And you know, we are only really focusing on symmetric, left skewed, and right skewed. And you can see when you look on Google, there are more than that out there. But in Algebra 1, 2, we're just focusing on symmetric, left skewed, and right skewed. In class on Tuesday, I mentioned that the height of adults is an example of a symmetric distribution. And if you look right here on the Khan Academy example, they used lengths of houseflies for a very similar reason. Flies get bigger and smaller equally likely. It's equally likely to be a super big fly as a super small fly, just like it's equally likely to be a taller than average adult or a shorter than average adult. So you get a symmetric distribution. The line that they drew right in the middle is going to be your mean, and it's going to be your median, and it's going to be your mode. So when it's symmetric, all of those measures should be almost equal. They won't probably be perfectly equal, but they should be very close to each other. Now, when I look at the next example here that they have, let's get rid of that. When I look at the next example, they have left skewed here, talking about the dates on pennies. It is much more likely for pennies to be recent than to be very old because they get lost or damaged or just destroyed. And so you can see what happened here, that there are very few old pennies. It has that shape where the tail is on the left side, and there are a lot of new pennies there. And what I can conclude is that the mean is going to be smaller than the median because the mean gets pulled by the skew. What I mean by that is if you lined up all the pennies in a row, the median penny will have a more recent date than the mean penny. Because if you add up just a few really small numbers, like 1960 is much smaller than 2000, just a couple of those small outliers are going to make the mean a lot smaller. The other example that I gave on Tuesday's class was about life expectancy, or the age at which people die. In the United States, we have a left skewed distribution that fortunately few people die when they are very young, and most people die when they are older. And that was another example of left skewed, and you can see it here with the dates on pennies. The other example that I wanted to point out from Khan Academy here was just this state representatives. This is a right skewed graph here. If you know about um, how the government works, the more people live in your state, the more representatives that you get to send to Congress. And so what you can see here is most states have very few representatives. Oregon has, I think, 4 representatives, so it would fall in this first category of the histogram. But then there are a couple states that are very large. California is the largest state, has a lot, looks like in between 50 and 60 representatives. I bet here you would see something like New York, and then maybe Texas and Florida here. And then from there on, there's a couple other states that are fairly big. I don't know, maybe an Ohio or something like that. But the point is that the mean is going to be bigger than the median. I can tell you the median is going to be in between 0 and 10, but the mean is going to be bigger than that because adding in a California makes it seem like states are bigger on average. So I just wanted to let you see a couple of those distributions and talk about them. And if you scroll through this image search, you can see that there's obviously lots and lots of different types of distributions that are actually out there. But in Algebra 1, 2, we focus basically just on these 3 shapes right here. And you can see in this shape, in this diagram, exactly like what I was saying, that the symmetric distribution have the 3 values, the mean, median, and mode are all the same and in the middle. When you have a left skewed distribution, your mean got pulled further to the left. And when you have a right skewed distribution, your mean got pulled further to the right. That's it, but please feel free to ask for either more examples of shapes of distributions or any other further questions about shapes of distributions. Thanks.